So hi everyone and welcome to this ThreeFold demo session. Today Scott will present a demo on private networking with IPv6 and WireGuard. That should be very interesting. So we will see how to use WireGuard with ThreeFold virtual machines to create stable private connections, and this can have several use cases, and it will be ideal for creating clusters and high availability setups. So without further ado, Scott, thanks for being here, and I'm very curious to see this demo.
Thank you, Meek. Let's jump into it. So our references for today, we'll be using Terraform a bit later in the demo to deploy sets of VMs that we can network together using WireGuard. And also the WireGuard document, quick start documentation will be a reference. I'll be showing that a bit later for some manual instructions on how to set this up. And what I'm going to be doing today is creating virtual machines, assigning them IPv6 addresses, and then creating a WireGuard network between those VMs, either manually or using Ansible. And what's cool about this is that we can connect any two IPv6 enabled nodes anywhere on the ThreeFold grid. So these can be nodes that are in like a home behind a firewall, and they can be two machines that would not normally be able to connect to each other without some kind of, say, magic sauce, something like Mycelium. But there's some nice reasons to prefer what I'm going to show you today, and I'll get into that in just a sec. First, a little bit about WireGuard. WireGuard is industry standard tool for creating end-to-end encrypted virtual private networks, simple, fast, and secure. And we actually use WireGuard inside of ZeroS. So WireGuard is a way that you can connect to your VMs. It's also a way that gateway nodes can connect to VMs to enable traffic to come into those VMs, even again, if they're on nodes that aren't reachable over the public internet due to firewall restrictions. But our WireGuard implementation in ZeroS is not available in the dashboard for groups of multiple VMs. So if you create VMs inside the dashboard, each one goes into its own private network and they're not able to talk to each other. And when you're using this feature of ZeroS, you don't have direct control over the configuration, so it's a bit less flexible. You're kind of stuck with whatever ZeroS provides you. And that's, I mean, it can be okay in a lot of circumstances, but if we want more direct control, then we can run WireGuard ourselves inside of the VM, and this will give us a bit more control over what's happening with that. And this, having that control is nice for creating sort of, let's say, dynamic clusters of VMs where we might have a situation where we want to have 3 VMs that are running some kind of service where they all need to talk to each other, like a distributed database or something like this. And if one of those VMs goes down, we want to replace it with a new one. And what I found in my testing is that the best way to do this is to have direct control over the WireGuard networking and do it yourself. There might be some improvements we can make in ZeroS and the deployment tools to make this a bit smoother for users, but for now, this is the best way I've found to support setups like this. Now, there are a lot of other options for creating private networks. These, for example, the most popular one people probably know about is called Tailscale. There's a number of others that are kind of in the similar vein. These are usually WireGuard based, not always, but usually. They offer easy setup and some additional features, things like access controls, things like something similar to our gateways, like a reverse proxy setup where you can bring traffic in from the internet. And these services are very nice, and I use Tailscale sometimes. I've tested it on ThreeFold Grid. Tailscale is great. There's ways you can use it. But for this particular circumstance, I wanted to have something that has no external dependency on an outside service. And sometimes these services are not fully open source. Like with Tailscale, there's an open source implementation of the backend, but that's something that you need to run yourself and you need to make sure that it is online. So in this case, I want to do something simple. We don't need an outside server. There's nothing else that we have to maintain.
And so WireGuard, this is really like the norm in the industry for a private network.
Yeah, so one reason that Tailscale is so popular is that, as we'll see, like setting up WireGuard manually is not trivial, and I'm just going to be doing a very basic setup. And if you want to get into more complex stuff, like if you have a lot of different sites and there's different network topologies, like that can quickly grow into something that you might not want to manage yourself. In this case, we have a very simple situation. I'm going to just have 3 VMs. That's all I'm ever going to have. And I just want them to talk amongst each other. So here, like setting up WireGuard manually or doing it like making an Ansible thing for it, which I'll also show, is not too bad. But what people tend to say is like, as your WireGuard setup grows in complexity, you tend to reach a place where it's really nice to use something like Tailscale or one of its alternatives, because it makes things a lot simpler and smoother. So yeah, WireGuard is industry standard, but I would say probably most deployments of WireGuard are done using some kind of wrapper around it. And yeah, so if you like Tailscale or something like it, feel free to use it. But today what I wanted to show is how you can use WireGuard directly. And this gives us it's a nice simple setup where we don't have to rely on something outside to provide our networking infrastructure.
So we're going under the hood, right?
Yeah, we're going one layer deeper. And this was fun for
Nice.
me because I had visited this setup guide from WireGuard several times and kind of thought like, maybe one day I'll get to it. And so I finally did. And that's cool. And actually, one
Nice.
last thing I'll say here, like one of the claims to fame of Tailscale is that it's able to connect machines that are behind NAT and behind firewalls and things like this. So as it turns out, like in this case, if our 2 VMs have an IPv6 address, that's very important in this case, we don't have to worry about that NAT aspect. We really only have to worry about the firewall. And thus it's actually pretty easy to get these machines to communicate, because firewalls are typically configured to allow traffic from established connections. So if we have 2 VMs, they both have an IP address. If they're both trying to connect to each other, then from the perspective of the firewall on each side, that looks like an established connection. And so it's going to allow that traffic back through. So WireGuard provides a built-in feature to keep those channels open. And so it's actually pretty simple in this case to achieve that sort of magic where you have 2 machines that can't otherwise communicate directly, and suddenly they can. And you also have the end-to-end encryption, which is nice. So I'll show that when we get there.
All right.
Yeah. And also, like, why do we want to do this? Well, because we can, and it's fun. And
That's all we need.
yeah,
That's a perfect reason.
So as I was saying, this enables direct connections between our VMs, and this provides us like the best latency that we can possibly get, because our traffic is never being routed through any other additional machines, like in Mycelium, where we always have to pass over a public node. And we get very good stability this way as well. It might be possible that Mycelium could provide a route in some cases around where maybe this WireGuard setup would not be able to do that. But for my priorities with this project, which is that I want to run distributed systems, clustered databases and things like this, that latency is the most important thing, and the stability there is going to be good enough in the majority of cases, because I'm also choosing nodes that are relatively close geographically. So it's not like we're going to have an undersea cable cut or something like that.
But
We're
they're not
going
in the
to...
same local farm, so there's some distribution there.
Correct. Yeah. So
Nice.
the thing I wanted to achieve is to have clusters of say 3 machines, so that you could scale this up, that are independent in different farms in different locations, so not likely to all go down at the same time, but still close enough that they can communicate with low latency and support, potentially, like I need to do more testing, but potentially be able to support something like Kubernetes, which is relying on etcd,
Mm-hmm.
and which really prefers to have low latency links.
Wow.
So
So are we going to test the latency later in the demo?
yes, we'll see that.
Oh, yeah.
All right, so without further ado, enough talk, let's demo time. So here
So
I've got the
maybe a
dashboard.
disclaimer, if you're at home and you want to try, Scott is a professional, okay? So be wary if you go into this territory.
Well, I wasn't a professional when I started preparing this demo, so you can quickly level up at this stuff. Yeah, here's the ThreeFold dashboard. I funded with some TFT. I've completed KYC. I'm ready to go with the deployment. I've attached an SSH key to my account. That's all basic stuff. I won't cover that today. I have SSH installed on my local machine. All that's documented in the manual, manual.grid.tf, and we can help you with any of that stuff if you need help. For today, we'll cut straight to deploying. In this case, I'm going to use full virtual machines. The reason for this is that the full virtual machine includes a kernel that has support for the WireGuard module. And one thing I didn't mention earlier is that WireGuard can run either in the Linux kernel or in the user space. And the kernel provides the best performance, but actually user space is pretty decent. And some of the private networking things like Tailscale, I'm not sure what Tailscale does if it runs in kernel space or user space, but some of those networks are using user space and they find it to be good enough performance. But it will just simplify our lives to have a full VM.
All right.
But you can make this work in micro VMs as well. And actually, for the second part of the demo where I'm showing the Terraform Ansible thing, that will be using micro VMs. So in this case, we want a public IP. I'm also going to grab Mycelium. I'm going to be using Mycelium for SSH access to these machines. So that's just from my machine to the VMs, and then the VMs will communicate amongst themselves over the WireGuard network that we'll create. Okay, so just basic VM specs here, IPv6, that's really all we need. And I'm going to look for a couple of nodes in Belgium. So when I check IPv6 above, that's going to automatically filter nodes that have IPv6, which is nice. And I'm going to use a couple of farms that I tested earlier. One is called Brussels. Node. So let's deploy our first full VM. And for this part of the demo, I'm going to be setting this up manually. And I'm just going to use 2 VMs and connect those together.
And let's say if I want to do this, I should not enable WireGuard, right? In the network that we saw.
You can. So if
It
you
won't
prefer,
interfere.
no, it will not
Okay.
interfere. So, and actually every VM, whether or not you check that WireGuard box, every VM, ThreeFold VM is going to get a WireGuard interface. So that's what the VM is using, like for outbound traffic to the public internet if it's going over IPv4. So there's always going to be a network interface there.
Okay.
And it doesn't interfere, yeah. So if you want to use WireGuard to connect to your VMs over SSH to set this up, you can do that. And actually all the steps are the same. You know, it's not going to interfere with anything. But today I'll use Mycelium. Mycelium is nice for this part. That will allow us to connect via SSH. So over here, I have 2 terminal windows open. So I'm going to be doing this side by side. So let's SSH to that first VM and then deploy the second VM. So let's see.
So for this one, we're staying in Europe, right?
Yeah, so I'm going to do 2 VMs in Belgium, and this will show us, what's possible in terms of latency. There's ways you could narrow this down further to find VMs that are close to each other, but Belgium's a small place, so
Mhm.
it works pretty well. Let's see, so again, I've enabled my public IPv6. One thing to note, if you deploy a VM and then there's a button over here I couldn't see or click on to like do it again, you have to hit IPv6 again. So
Okay. And it's the basic specs with you just change the name, right?
yeah, I mean, I'll take the randomly generated name, and the
Okay.
specs are, up to you, whatever you need for your workload. Today I'm just demonstrating the networking, so it doesn't really matter. All right, so here's another farm in Belgium. I'm just select this one and plug in. So while that one's deploying, let's just pop over here and see what we're going to be working with. So this is the quick start guide from WireGuard, wireguard.com/quickstart. And what I recommend if you want to try this is actually to watch this video, because the stuff down here doesn't exactly match the video. This is overall a good resource, but they did some things that are kind of confusing here. So basically, I'm going to be doing what they show in the video, but I will copy some of the commands from
Mhm.
down below here.
So we know it works perfectly with the ThreeFold Grid.
Yeah, well, we'll know it works after I've finished the demo, if we manage to succeed.
All right.
Okay, let's move this zoom control button. So I can see okay, so 2 fresh Ubuntu full VMs. First thing I'm going to do is an apt update install. This is going to install the tools that we need. WG command line tool. So I'm just going to run this in both VMs and let that fly by. Now, the first step here will be to create a virtual network interface. WireGuard to use. And this will be the same on both machines. And actually, a lot of these steps will be the same on both machines. So let's do this on both sides. So IP link add. And once I've done that, if I run IPA, which is short for IP address, we'll see that we now have this WireGuard 0. So I gave the name here, WireGuard 0, type WireGuard. So now I have a new network interface in my VM that is called WG0. We can see the existing network interfaces. So this is the WireGuard provided by ZOS. So this is an address in the 10.20 range. Here is our public IPv6. And here is our Mycelium. Here's our WireGuard. So,
And how do you know this?
well, we know the Mycelium address because it falls like addresses that start with 4 or 5.
Mhm.
If it says INET6, IPv6, and it starts with 4 or 5, that's going to be a Mycelium address. Public
Is
IP
it
address
4 or
is
8? Is it if it starts by 4 or 8?
4 or 5.
Okay.
Yeah, so Yggdrasil is going to be 2 or 3, and with 200 to 300 range.
Mhm.
And then let's say real public IP addresses are typically in this like
Okay.
2000 range. Just based on how the allocations, the currently used allocations of IPv6 addresses, and then the section of IPv6 address space that we've kind of hijacked for Mycelium. All right, so one thing I want to quickly just demonstrate here is that these machines cannot communicate over their public IPv6 address. So like, for example, if I take this IPv6 address here and I try to ping it from this VM, it doesn't work. And
Uh-oh.
likewise, if I take this IPv6 address and I try to ping it from this VM, it also doesn't work. So these VMs can't communicate on their IPv6 address because of the firewalls at the farmer's router. And it's actually, that's good for the farmer. Their network is not allowing inbound traffic. But as I was saying before, we can still connect these VMs, and that IPv6 address is going to be instrumental in making that happen. All right, so now we'll assign each of these WireGuard interfaces an IP address. We'll just use the example here, which is 192.168 range. You can use that. You can also use the 10.0.0 range, but you'll want it to be different. If you use that range, you want to use a different range so it doesn't conflict again with the existing one here. So this is 10.20 and this is a /24. So you could even just like change this, but I mean, if you change this one, then you'll definitely be safe. So if you want to connect your VMs on another 10. something network, you could choose 10.21, for example, and use that. But I'll just use the 192.168 example here.
So we're on the safer side.
Yeah, it's fine either way. This will just help us to
it's very safe.
Keep things straight. Yeah, super safe. So this one I will assign the 2.1 address, and then we'll see it down here. So this WireGuard 0 interface on this VM has that 2.1 address. And then on the other side, we'll assign it 2.2. So this needs to be a unique address for each VM, and we'll see the same thing down here, 2.2. Okay, so now each of our VMs has an IP address on its WireGuard interface. And now, so we're going to, so it's showing you that, so we just did this, and it's this or this, so we'll add the peer later. So we did this one, and then it's this or this. So this is if you have a config file, which might be nice if you're doing this more permanently, put stuff in a config file. But for the demo today, I'll just show doing everything via CLI. So here's where we would need to add the private key, but we don't have a private key yet. We need to generate it. So let's come down here to key generation. I'm going to run this umask command, which just basically helps us with some file permissions. So we'll do that on both sides. And then we're going to generate our private key. And in this case, I'll just keep it in like the root home folder here. But you can also put these under like, let's see, WireGuard would be like a typical place to put that. We'll just keep things simple. We'll use some path here. All right, and this command is how we're going to read that private key back and create a public key from it and then save that in a file. So let's do that on both sides.
That's a nice command.
Yeah, got the arrows going in both directions. So we read the private key file into this WireGuard public key command and then save the contents into a public key file.
Okay, great.
So on both sides, we now have a private key file and a public key file. Actually, I won't actually be using these public key files, but they're there if you want to look inside of them. Okay, so now we've done that. We have private key, public key on both VMs. And now we're going to set up the listening port and the path to the private key. Example path, so put that just to make this clear. So this is the file in the local directory called private key.
Very clear.
And we'll run the same thing on both VMs. Because there's dash. Again, there's some parts of this tutorial that are a bit confusing because they use a different font name.
But overall, the
Generate
steps are very
keys.
clear.
Yeah. So you have to interpolate a bit, but hopefully if you follow along with me or with that video. So again, if you come back here and you come to this video, you know, they do everything the same way. So you can follow along there. And I'm going to skip the peer part here because we can add the peer later. So I'm just doing the initial setup. And then the final thing I want to do is bring up the link. So I can show you if I do IP address again, we see just point to point, no ARP. And then once I do this link set up, dev wg0, now we'll see that we're up and
Aha.
lower up. What does lower up mean? I don't know. We're up. Okay, so now we we
It
have
means it's good.
yeah, up is good. So now we have our WireGuard virtual network device set up on both machines. We have our private keys configured. We're listening on the same port on both sides. And the final thing to do is to add each of these machines as a peer to the other machine. So that's the part that we see here, peer. So I'm just going to copy this and then we'll make some changes. So since we already set this listening port and the private key, so we don't need to do that again, although it wouldn't hurt if we did. I'm just going to delete everything up to where it says peer here. And the peer, the argument that we pass here is public key. So I'm copying the public key from this side and the peer on this side. Allowed IPs, so that's going to be, we can actually set this to just be the IP for this this machine here, which I can't see because it's off screen. We can just set it to be this, or we can set it to be a range of IPs. So I'm just going to copy that, and then I'm going to set this to 0, which just represents the full range that's covered by this 24. And then finally, for the endpoint, I'm going to set this to the IPv6 address here of this VM.
Okay.
Wrap it in square brackets because we need to also specify the port. And that's going to be the same port that we use on both sides. So that's the full command to add the peer. After I do that, I can run WireGuard again, and we'll see that this machine now has peer configured. So now I'll do roughly the same thing on the other side. I'm just going to change the public key to be the public key from this one. And I'll also need to change the endpoint. Just delete this IPv6 address and grab the IPv6 address from this machine. Port is the same. The allowed IP, since we're using a range, we can leave it the same for both. And do that. And now we can see that this machine has this one as a peer. So now both machines are configured with the other machine as a peer, and with that, we should be able to ping 68 to dot. It's the address in this one. Actually, there 2.1. Okay. And can we ping? No, we cannot. Let's try.
So do we need to enable to set it?
I need to bring the links up again. Let's see. And this one's fairly again. We should see them.
Aha.
Transferring.
So this is when you first ping, I guess?
Well, this is what we get for doing the live demo.
And can you try the other one maybe?
Yeah. Okay, so
Oh, so you have it one side. Ah, you have it. It just took some time, right?
yeah, they might have needed some time to connect. So that's this thing with the two connections needing, for the firewall to open up. So
Mm-hmm.
that can take a bit of time.
Wow. Did you
But we
feel
did
that
it.
at home? We made
Yeah.
it. Well done.
So, and we can see we have about a 25 to 30-second ping between these machines,
Mm-hmm.
which is pretty good. Let's compare. So
Because we're not in the same LAN, right? As a reminder,
it's
they're not even in the same location, so this is pretty good.
yeah, I'm not sure about. I think one of these nodes is in Brussels, of course,
Mm-hmm.
farm name. I'm not sure about the city of the other node or how far they
Mm-hmm.
are. But what we can also do is try to ping each other using Mycelium. So let's check that for comparison. So
Nice,
we're
good idea.
we're doing pretty good here. These are
Almost
they're
50% more in a lot of
yeah,
cases.
30 to 40 milliseconds. But let's try the other one. What I can tell you is that when I was trying this before, I was sometimes seeing about a 40 millisecond ping, but I was also sometimes seeing a 100 millisecond ping.
Mm-hmm.
And that I think is the biggest, like you can see here, like Mycelium can be
No,
as good or almost as good,
almost.
but it can also change, like it can be quite variable. And that's the thing, like Mycelium is optimizing for always connecting machines and making sure we can find a route. But there can be times for whatever reason that traffic takes a longer route.
Mm-hmm.
Um, so that's for compare and contrast.
Mm-hmm.
And again, I should also say that this is like best case scenario because we have public Mycelium nodes in Belgium and also throughout Europe. So
Yes.
if you were to, I was looking actually for like some nodes in Australia or New Zealand or something like this. I couldn't find two that
Mm.
had IPv6, so I
Okay.
didn't do
So
it for the
farmers
demo.
out there, we need you. Bring
Yeah.
nodes online with
Well,
IPv6.
there's nodes there, yeah, but I guess the ISP is not supporting IPv6. But the
Mm-hmm.
point being, like this will work anywhere in the world, and the Mycelium pings might be a lot. Like this is probably the
Mm-hmm.
best kind of the best case for
But
Mycelium
do you
pings
think with the
between.
upgrade that are coming for Mycelium with maybe a private network or well, it's nothing set in stone, but just to discuss for fun. Do you think
Yeah, I
this
mean,
would help?
I think it would be cool if Mycelium could get features like this,
Mm-hmm.
perhaps. But in general, like your Mycelium traffic between nodes is always passing over a Mycelium public node. And
Mm-hmm.
so if you don't have a Mycelium public node close to you, then it's always going to, your
Yes.
best case latency will be the time to get to that Mycelium node and
Mm-hmm.
come
Mm-hmm.
to your destination.
And in the case of this demo, so what's happening? Let's say how the nodes communicate. It's all over IPv6, right?
Yeah, so well, for the Mycelium links, I mean that's happening over either IPv4 or IPv6, and that can go either way for the Mycelium base traffic.
Mm-hmm.
Um, and then Mycelium provides an overlay that uh,
And for those two,
carry.
let's say the VPN we just did.
Yeah, so that's going over. So in the case of the WireGuard network, we
Mm-hmm.
have IPv6 as the underlay, but then we're using IPv4 um, as the overlay. So like this
Okay.
192.168 is an IPv4 address. So we have IPv4 running on top of the
Mm.
underlying IPv6. But yeah, that piece is not super important. Um, But in terms of how the VMs are communicating, so with the WireGuard network, it is point to point over between those IPv6 addresses. In the case of Mycelium, we have a Mycelium public node, at least one. And so any traffic from this VM needs to go to the public node and then to its destination, likewise, and then return route. All right, so that's that. And once we've set that up, then we can use these 192.168 addresses for our workloads, right? So we can install software on this VM and provide it the WireGuard IP from this VM, and those VMs can talk and do almost anything.
And should we add, let's say, SSH key if we want to SSH from one to the other?
If you want to, yeah, but in the way I have this set up, we're always doing SSH from my laptop, from our control node, shall we say, to the VM. So
All
yeah,
right.
if you want to SSH between the VMs, or you have a workload that requires that, you could certainly set that up. That might be nice for like doing file transfers, right? If you want to transfer files over SCP between the VMs, then yeah, you could set up SSH. You could generate some SSH keys on these VMs and add them to the other VMs as authorized keys.
Nice.
So yeah, you could totally do that. All right, so let's flip over. On the other side here, I have my Terraform and Ansible thing ready to go.
So next
So
level right there, right?
yeah, so if you're thinking like, wow, that's a lot of steps, and
Mm-hmm.
you know, yeah, it is. And of course, we can automate this because it's computers and
Yeah.
we're all lazy, right? That's why we
Yeah.
like computers.
Clever,
They do
clever and lazy.
right. So let's see how we can automate this to make our lives easier and not have to ever think about all these commands again. All right, so I'm going to be using Terraform to create, in this case, 3 VMs, and then I'll be doing the WireGuard networking with Ansible. This is our Terraform provider for ThreeFold Tech Terraform provider grid on GitHub. And I want to show you, if you come in here for the examples, resources, there's the single VM with Mycelium. So this is the base for what I'm using today, and I basically just took this and made 3 copies of it inside of a new file. So
Okay.
in terms of setup, like that's really what it is. I added the public IPv6. So let's flip over now and look at my Terraform file here. Just open it with a text editor in the terminal, but you could use your VS Code or whatever you want here. So our grid provider takes a mnemonic, takes a network. In this case, I'm using mainnet, takes a relay. This is important now to set this relay.
Oh, yeah.
In this case, I'll be using the mnemonic and network from my TF bars file so that I don't put those into this file that I'm showing to you. I'm going to create a few local variables. So I'll give this cluster a name. This can be useful if you want to deploy multiple clusters and they have a unique name. This is just our base micro VM image for Ubuntu. And then I have my 3 node IDs.
Nice.
So this is, in this case, this is FreeFarm. This is another node in either Belgium or Netherlands. And this is a node in Roberts Farms. Okay, so for Mycelium, we need to generate some random bytes. And that's just part of the Mycelium setup. This again, we just copied and pasted it and just gave these names like 1, 2, 3. Now for each VM, they're going to get their own network. So in Terraform, you can put VMs in the same network, and that's how you get our sort of baked in WireGuard functionality. But in this case, I'm just going to make 3 separate networks for the VMs because I'm not using that baked in WireGuard functionality. And I actually ran into some issues when trying to create and destroy VMs in an existing deployment. So if you want to test, you want to try to replicate what I'm doing here, I actually recommend that you use separate networks, at least for now. Maybe some things will improve later and that won't be necessary. But this, so I now have a network and a deployment for each of my 3 VMs. They all look the same. They just say 1, 2, 3. And the main thing, like I said, that I changed from the example is just adding this public IPv6 true. So I get a public IPv6 address. This would be for public IPv4. I don't need that. And yeah, that's basically it. This is just standard stuff from the example file. There's 3 of those, 3 copies.
So it's 3
and
times the same.
yeah, 3 times the same. And then I also have outputs. So I output the IPv6 address and the Mycelium address. So if you're following the example, like that probably won't have the IPv6 address. And then the final thing here is generating an Ansible inventory.
Oh. So you generate the inventory right there
Yeah, we do it like
at
this.
Terraform.
Yeah. And here I'm specifying my WireGuard IPs. So again, we want to make sure that these are different than these, right? So in this case, I'm using the range 10.42. And I've just assigned the IPs here. There might be a clever way to do this dynamically inside Terraform, but I didn't bother with that. I also have some Prometheus stuff down here. I'm not going to show it today, but part of my clustering setup is also having automated Prometheus deployment using Ansible. That's
Nice.
just in there. Yeah, in case, so that you can also use that one. I'm not
So
going to show
maybe
that
for
today.
a future demo.
Yeah, for sure. I would love to show, once I get get things going a bit deeper, show the whole thing. So yeah, the idea here is you can monitor your cluster VMs using Prometheus. And this, I'm just going to write it into a file called inventory.ini. All right, so that's that. And normally you would want to come in here and do Terraform init. So I've already done that, so I don't need to. And then I can do a Terraform apply and won't do an auto approve, so I have a chance to see what's happening here. But this is just standard Terraform stuff. We do an apply. It's going to show us everything that it wants to do, which looks like a lot, but again, it's just 3 copies of the same, all the same stuff that it's done. So let's let her rip, as we say. I'll also go ahead and split this terminal so that I have another one to show the Ansible stuff over here on the side. And
So usually, let's say if you use Terraform and what we do, let's say in other demos that we do a VPN with WireGuard, we use only one network usually, right? But then how you set it up here, it's one network per VM.
that's right, because we're going to be providing our own private network among the VMs. So
Nice.
we don't need to use that built-in feature. And
Okay.
as I was saying, I bumped into some issues with trying to, say, replace VMs. And
Yeah.
that's one thing I wanted to make sure I can support in this
Okay.
setup, is if a node goes down and takes your VM with it, that you're able to swap that node for a different node and recover, right? All right, so our deployment is complete, and we see here the IPv6 and Mycelium addresses of our 3 VMs. And we also have, I'll show you over on this side. So we also now have an inventory.ini file, and we can just look inside there and see, like, basically what it's done is filled in the Mycelium address and the IPv6 address for each of the 3 VMs and filled in the WireGuard addresses. So this is how Ansible will know basically how to set up WireGuard on each of the 3 VMs. And then to run this, I'm just going to run, actually what I'm going to do is cd into the Ansible directory and also inside. So in here I have my WireGuard thing, I have my Ansible config and Prometheus thing. I'm not going to step through everything that's in here because it's, shall I say, still cooking. But when this is ready to share, I will share it. So yeah,
That's good.
this is not quite ready for public consumption, but this at least can give you a sense for what your experience could be like if you're using Ansible to automate this. So I'll just point this thing at the inventory file that's in the folder above. I'm going to run our wireguard.yaml playbook, our playbook thingy. And I will let Ansible do its thing. basically, it's going to go through all the steps that I just did manually on those two VMs. So we're going to install some packages. Actually, in this case, we're going to use the user space.
Yeah, so that's the difference, right? Instead of the other method with full VM, now with micro VM we do namespace.
Yeah, user space
User space.
WireGuard. And basically all that means, well, there's a few things that it means, but we just basically change one command name, and then we need to make sure that our user space WireGuard executable is running. I did it this way because I was already working with micro VMs and ZInit, and I wanted to keep that stuff.
Mm-hmm.
There is a way to make a VM that has ZInit that looks just like a micro VM basically, but has the kernel that supports WireGuard.
Yes.
So that's another project,
Mm-hmm.
and maybe I'll get that going. But for now, we can use user space WireGuard, and it's, like I said,
Looks
it's
good.
good enough. It
Mm-hmm.
might not have the absolute best performance, but you know,
Because there are more overhead or
yeah. So the reason for that is that the kernel's job is to communicate, or one of the kernel's jobs is to communicate with hardware. In this case, our hardware is the virtual network interfaces that are provided to the VM by 0S. So the kernel is doing the networking. And so if we run our WireGuard in kernel space, then it's in the same space, the virtual networking, which ultimately has to go over like our IPv6
mm-hmm. Okay.
connection. So that's all happening in kernel space. If your WireGuard's in user space, then you need to be basically pushing data back and forth across the user space kernel space boundary,
Mm,
and that's an operation that has some overhead.
okay.
Yeah, so that kernel-based implementation of WireGuard is so highly optimized. But there's some cool stuff happening. The one I'm using currently is WireGuard Go, but there's also Boring Ton, which is a
Okay.
REST implementation, and then there's another.
Mm.
They have WireGuard RS, which is another REST implementation.
So is
So
it like a fork of WireGuard or it's just a different flavor?
yeah, different implementation of
Okay.
the user space
Hmm.
stuff. Yeah. So I haven't tested Boring Ton. It might have better performance than WireGuard Go. WireGuard Go, I think, is the most tested and stable.
Mm.
And then they're also building a Rust implementation.
Oh, always Rust and Go. They those names they always come up for the modern stuff.
Yeah, for high performance, you need high
Mm-hmm.
performance. That's definitely important.
Yeah,
Okay, so this is actually finished. I
finished a while
couldn't,
ago. To
yeah, I
be
couldn't.
clear.
My Zoom toolbar is down here blocking. So yeah, so this actually doesn't take much time. It's much faster than me doing it manually and
Yeah,
explaining everything.
that's great.
But we can see the steps here. I mean, install some packages.
Mm-hmm.
We'll make that etc WireGuard thing. We'll make private keys, public keys. We're going to read those public keys onto our local machines so that we can set them for set all the peers. In this case, I'm making a ZNet service. When you use
Okay.
user space WireGuard, you need to make sure that your user space WireGuard executable is running. So I'm keeping that running with ZNet.
Okay.
We'll start it up, then we'll set it up. In this case, so this one, it is clearing out the peers on each run, because if I replace a VM with a different VM, I want to refresh the peers list. So every time I run this Ansible playbook, it's going to clear and replace all the
Okay.
peers to
Nice.
make sure that we don't have like old peers hanging around.
And it's idempotent too, right? I guess.
Well, that part isn't actually. It's, well,
Oh,
it
because it
is.
can be new peers.
Yeah, so it's idempotent in the sense that if you have three of the same VMs and you run it again, it's going
Mm-hmm.
to clear the peers and add the
Yeah.
same peers. So you have the same
Okay.
outcome,
Okay. Okay.
but it's not, I mean, with Ansible, they're often using idempotent to describe an operation that isn't performed
Mm-hmm.
if the outcome would be the same. So in that case, in this
Yes.
case, we're not doing that. Like
No,
we're
you
just,
run it every time, but you know the
yeah,
output will be the same. Got
right.
you.
So if
Nice.
you change your VMs, if you change the nodes, you change the VMs, then it's going to make an update. If you
Mm-hmm.
don't change them, it's still going to blow away the old thing and just
Yeah,
replace it
yeah.
with what was there before.
Nice.
There's probably a more clever way to like make this do less work, but in this
Mm-hmm.
case, it's
If
like,
it works. The
yeah, it's
work
not
is by
really,
the computer. That's good for me.
yeah, and it's not a long thing that we do here.
Yeah. No, that was
Probably
quick.
for the next version, what I'll actually do is use a WireGuard config. So what
Okay.
this will do is write a config file.
Mm-hmm, mm-hmm.
Um, and what we can see here, so it adds the peers and it only does, so there's 3 VMs and it only adds the 2. So like for node 1, it skips node 1 because that's
Mm-hmm, mm-hmm.
itself, right? So for each
Nice.
VM, it skips itself and then adds the other 2 peers. Alrighty, let's just take a look inside of one of these VMs and see
Mm-hmm.
what happened. So SSH to this VM and let's check IP. Okay, so we see here we have our WireGuard interface. It's been assigned an IP. And if I run WireGuard, we'll see that we have our 2
Nice.
peers configured and
Mm-hmm.
we are handshaking, which means that we're
Can we ping them
connected.
now?
Let's try it.
We want to see. Oh,
We
yeah.
can.
Oh,
So that's a nice,
16.
yeah,
That's
let's check
good.
the other one.
Hmm.
It's 10.
Oh, let's
And then
do
we can
some
do,
eye available stuff.
yeah, this is very nice, right? And
Yeah, very good.
these are in different farms. So let's try
Mm-hmm, mm-hmm.
Mycelium.
Oh, yeah. The battle. Oh, it's good.
Yeah, not bad. I'm not sure.
But there's a consistency in the difference between the two methods.
Now we're seeing
Oh,
some rather large pings here. So
yeah, yeah. 635, that's crazy.
yeah, so on the
Hmm.
direct connection, we had 10 and 15. And
Yeah.
over Mycelium, we have
Mm-hmm.
25 and maybe 100, maybe
Yeah, yeah.
200. I mean, if we let this run for a while, we might see some better ones.
Is it the same? You just ran the same command?
Yep, so this is the same
Whoa.
node, but suddenly it's better, right? And this is the thing, like
Okay.
Mycelium, the routing, it can change and
Mm-hmm.
it's often pretty good,
Yeah, yeah.
but it can vary. And
Mm-hmm.
that's probably something that will improve with future versions of Mycelium.
Mm-hmm.
Mycelium's still an experimental
But
technology.
the first goal was like for resiliency, right? So if it's lost connection, it can go somewhere else. So I guess by design that the focus was not yet on speed, but on resiliency. Do you agree?
Exactly, yeah. And so Mycelium, the thing that it does really well is that you can take 2 machines anywhere in the world and you have a very good chance that you can make some connection between those
Nice.
machines,
Mm-hmm.
reasonable connection to do your SSH or whatever.
Mm-hmm.
Yeah, it's not optimized yet for always giving you the lowest latency link between 2 points.
Mm-hmm.
And again, like Mycelium is always going to involve another hop over public nodes. So
Yep.
there will always, even in the best case, there will always be
Mm-hmm.
a bit more latency. Okay,
Nice.
so that was fun, but let's see if
Yes,
we
that was fun.
can, let's see if we can, let's say that one of our machines went down and we
Oh,
want to
okay, the real
replace it with
test.
another one. Now,
So that's the dangerous part we were talking about earlier, guys. Don't do
yeah,
this with production workload. Don't test this
this is,
apart from a testing environment with the nodes you want to test.
so I probably, preparing for this demo, probably 20% of the effort was everything that you've seen so far, and the other 80% was
Oh
this
yeah,
interface.
I believe you.
Picture.
Okay,
Let's say,
let's go.
okay,
I'm curious.
So let's say we had node 920 here. Now node 920 goes down. Its disk goes bad, or it's something gets fried. So if I want to just replace this with node 921, which is another node in Freeform, so in that regard, we're somewhat cheating here, but it's still just to show the concept that we can replace this with the
Yes,
node.
that works for me. I'll be impressed if it works.
So let's apply again. And what this is going to try to do is replace the VM we had with a new VM. And didn't go so well. Let's try again. Like I said, we're getting into the danger zone here.
Yeah, but sometimes you just need to redo it, right, with Terraform? Oh.
Yes. So we tend to have some occasional failures that are transient.
Yeah.
So this happens. I mean, again, we're already working with distributed systems, so sometimes we can't reach the grid proxy. Sometimes we have an RMB thing that happens. And sometimes we have to try again. Hello, Jen, and welcome. We've already completed most of the demo, but I'm just showing the last bits here.
Yeah, you're here for the challenge.
Yeah, we're here for the hard part.
Yeah,
Up
so
until
maybe
now,
just
everything went smooth. So.
Yeah. So small recap. What we did here, Scott. We did a VPN with 3 different VMs on the grid, and now we want to remove one from the let's say the cluster and add another one.
Okay. So I'm replacing one VM with another VM on a different node. And let's actually see if we can. I don't know if this is the VM that we're replacing. Yeah, I think it is. So we can't reach that one anymore. But let's try to connect to one of the others and see if we can get a sense for what's going on.
All right.
We should be able to see that VM.
Oh, looks good.
Cluster.
On the left.
Okay, yeah, so our deployment completed. But we should now see that one of these we can't reach. That must be the one that's still around, and this would be. So this is the VM that we decommissioned. So, oh no, we can't reach that one anymore. And we have a new VM. We want to add this to the cluster. Oh, so I forgot one thing that I need to do here. I actually need to remove the existing inventory.
Okay.
Because there's probably a way to tell Terraform to overwrite it, but
yes,
I didn't get that far yet. I was coming down to the wire here. So I'm just going to apply again, and we can actually see the inventory file that's going to write. If we didn't do that, then.
But this should be quick, right? Because it knows it already deployed. It won't have to redeploy. It just reprints the inventory.
Yeah, I don't know why there's modifications happening here. That's kind of a mystery to me, but for some reason it thinks it needs to modify something. All right, so now I'm going to run my playbook again.
Because your inventory is updated, so you can just rerun it. Then that's the new VM that we put in there.
Yep. So this is the process. We want to update the main.tf file with our new node ID. We want to redeploy. So we deleted the old VM. We made a new VM. And then I'm going to run the Ansible.
That's nice.
Playbook again. And it's going to, so it's going to install it's going to set up that new VM with everything that it needs. And then it's also going to go into the other 2 VMs and replace the peers list so that all 3 VMs have the correct peers.
So let's say if we were running, let's say, an app that is among all the three VMs. What we could have here is that if you lose connection, then you reboot another one, and then maybe with the Ansible playbook, you would resync maybe the database from the two VM that are still on.
Yeah, so after you did this, then maybe you could have another playbook, right, that would update the cluster membership in your database.
Okay.
That would, yeah, maybe bootstrap that new database with a copy of one of the existing nodes. That kind of stuff, yeah.
Nice.
Which you can also do manually. I mean, that's a nice thing with Ansible is you can work somewhat incrementally. So, you know, if you just want to manage like your basic stuff, like your WireGuard networking, and you want to do the other stuff manually, that's fine. So what we can see here is, you know, we only have one, like, since we replaced one VM, then the tasks here that have this idempotency thing, they will only happen on one VM. Some of these probably like generating this. I could probably improve that a bit, but again, these tasks, if they're repeated, they just do the same thing that they did the first time. So they are idempotent, but we might have some repeated work. Okie dokie, so that's all done. Now let's
ping.
Let's try it out. So I will switch. Let's connect. I think this is our new VM. Oh yeah, it's the new VM. So one thing that's interesting here is because we're using this method where we set the Mycelium keys in our Terraform file, we'll actually have the same Mycelium IP for the new VM. And that's why I needed to do that host keys thing.
So it means it's the same public address?
Yep, same public private key pair. All right, so let's see if we can ping these other two machines. That's good.
Nice. So now we're in VM1 and we ping the other VMs.
Yep, we can reach the other two VMs. So
very fast.
Yep, and that's actually enough for us to know. Well, we don't know that we know that it's mostly correct, right? We want to also check that the other two can reach each other. But for today, I think that's enough to hopefully convince you guys that this works, and it can be a nice way to create groups of VMs that have a low latency connection among them, and that is flexible. We can add and remove VMs, and
yeah, that's very nice.
Simple way, like update the config and get everything talking again.
So that's a very good basis to then add, let's say, a high available workload.
Yep. So if you want to make cluster databases and things like this, then yeah, this is a nice foundation for that, because those tend to benefit from low latency and reliable connections, of course.
Yeah, and that you can just reset another VM.
Yeah, totally. And being able to.
So what we did here, we had three VMs, then we removed one, we put back another one. Could we have three VMs and then we add a fourth VM?
Yeah, so the way this Ansible playbook is set up, like it will, and Terraform thing, yeah. So the Terraform part, you would need to add the fourth one, but you could do that, and yeah, the Ansible thing will work with whatever inventory you give it.
Nice. All right. Well, thanks for the demo.
Well, thank you so much, everyone, for stopping by today. And thank you also to everyone watching the recording later. We appreciate you as well. Some connectivity problems. Well, no worries, Jen. The recording will be available, and if you have any questions, I think you know where to find us.
Thank you, Scott, and have a good day. Thank you, everyone. See you at the next demo.
Thank you, Scott. Thank you, Nick. Bye-bye.
Thanks, Cameron. See you. Bye.